Hello everyone and welcome. This webcast is called Protecting Privileged Domain Accounts During Live Response. I am Bobby Steffes with the SANS Institute and will be moderating this webcast. Today's featured speaker is Mike Pilkington. He's a senior security consultant with a large oil and gas company that he's not able to disclose the name of. Before I turn things over to Mike Pilkington, the Q&A will take place at the end of the webcast. Feel free to submit your questions at any point by using the chat window located to the bottom left-hand corner of the screen. All right, right now I'd like to introduce our featured speaker, Mike Pilkington.
Okay, can everyone hear me? We did a little bit of a test there before the little glitch with the webcast, but I think we're good, so I'm going to move on. I appreciate everyone joining. This is a real pleasure, and I hope it proves useful for you. This is a topic that's been of great interest to me for the past couple of years, and so I've done a lot of research in the area, and I think it's something that's useful for sure for incident responders, but for many folks out there that are securing Windows networks. And So basically this presentation was really born out of a curiosity and frankly a paranoia for what happens when I logged into a compromised host with my privileged domain accounts for doing incident response. So I was constantly changing my password, and that got old, so I decided it's time to really dig in and figure out exactly how my accounts could be exposed when authenticating and logging into to a remote machine. Seeing that we can't hear very well, so I'm going to turn up the gain just a little bit and see if this will work. Let me know if this is maybe a little better. So again, from everything I've done, I've had the opportunity to give this presentation a few times and also to create a few blog posts for the SANS Forensics blog. And I actually have a new one that's just about to come out. I've been able to post on most of the topics, but the last topic I hadn't gotten out there yet, so it should be available pretty soon. So still trying to figure out the audio just a bit. Okay. All right, so I'm going to press on. All right, a little bit about my background. I've been with the same company since 1996. I graduated from the University of Texas at Austin with a degree in mechanical engineering, and unfortunately fortunately for me, because I got into computers and really enjoyed it, but I didn't use much of my mechanical engineering degree other than to get a job with my current company as a software tester, testing some applications on Unix, and that really got me involved and interested in computing. And so from that point on, I've done system administration, network administration, security analysis, all types of things. And for the past 5 or 6 years, I've really been devoted towards forensics and incident response. Of course, I also get roped into a number of projects here and there. The latest one is log management, which seems to be just kind of an ongoing project, a never-ending project, but a critical one nonetheless. Outside of my day job, I've had the opportunity and the great pleasure to be involved with SANS and particularly a forensics program as a teacher and a TA, and I've really enjoyed the time that I've been able to dedicate to SANS functions and classes, and it's been a really good opportunity for me. So I wanted to take the time actually to promote an upcoming course in Reston, Virginia. And this course is the Windows In-Depth Forensics 408 course. It's the introductory course in the SANS Forensics lineup, but it steadily ramps up, and anyone who takes it will see that it quickly becomes an intermediate to advanced level class throughout the week. So it's a great class and a lot of fun. So hopefully some of you out there can join me in Reston, Virginia. And as you see at the bottom, we've got a nice incentive there to sign up by October 3rd for the course. So let me also take a couple of minutes just to brief you guys on the overall SANS Forensics curriculum. As I mentioned, 408 is the introductory course, and it's it goes into a lot of depth and a lot of details over how to do forensics on a Windows-based host, and again, it covers a tremendous amount of material over that week. And I've seen a number of old forensics pros take the course and rate it highly and get lots of tips and tricks from the course. So both those new to the subject and old hats can get a lot out of Forensics 408. Now, Forensics 508 has just gone through a very thorough makeover, and at this point it's really what I consider a one-of-a-kind course for learning forensic techniques for hunting and finding advanced malware. It teaches how to sift through a lot of noise and find the targeted attackers and targeted malware in your environment. Rob Lee did a tremendous job of building up a really lifelike enterprise environment for students to do essentially instant response at scale. And we have, the goal is to basically analyze multiple systems simultaneously to find, both malware and evidence of lateral movement and exfiltration and all of the things that we deal with in an enterprise level incident. So what you see on the right is kind of the progression of courses. It's not set in stone, but the first two we really do recommend taking 408 first and 508 second, because at this point they're almost the same class spread over 2 weeks. You could almost consider it. They just 408 feeds into 508 so nicely. And then at the bottom we have a number of other very interesting forensics courses. We've got a network forensics course, mobile device forensics. We've got a brand new class from Jesse Kornblum, a memory forensic in-depth course, and this is just being tested in beta right now, so it's going to be very, very interesting. Looking forward to that. And of course, the reverse engineering malware from Lenny Zeltser is a great course as well. All right, so without further ado, let me jump into the presentation. And what's happened after studying this issue for quite a while now is that I've really boiled down the risks that we have and the ways that we need to defend our privileged domain accounts in 4 areas. And these areas are, which I'll go through in depth throughout this presentation. The first one being password hashes, and this is of course how we store our credentials on our machine in a way other than a clear text password. This is kind of how the passwords are stored on the machine. We've got encrypted passwords, which is actually a new finding very recently, and it's essentially a single sign-on functionality that's in Windows that was, as I mentioned, just discovered very recently. And we've got access tokens, and we've got network authentication. So I'm going to hit each of these in depth as we move through the presentation. Now, all of this actually boils down to really 3 things that you can do to protect your accounts. Avoid interactive logons, specify account logon cannot be delegated, and this specifically goes towards access tokens, and enforce Kerberos network authentication. So you see these 3 things, you might think, wow, it'd be great if I could just do these 3 things and protect all of my accounts throughout the environment. The problem is that first one is a real gotcha for most accounts. So interactive logon, as I'll discuss more soon, is essentially what gives you a desktop when you log into your machine. So if your standard accounts where you're doing email and web surfing, then that one's pretty much off the table. And in fact, this is what really creates many of the vulnerabilities we have with our domain credentials. But for targeted, kind of purpose-built, privileged accounts, these turn out to be 3 things that we can do in many cases. So that's a great win for us as incident responders and folks trying to secure our overall environment. So as I mentioned, my whole goal in starting out this research was really an incident response mission. I wanted to figure out how I could interact with a remote machine that's probably compromised and do it in a way that's going to protect my credentials. So I set out to build kind of an environment, a test environment, and my overall mission was really what I considered like a realistic yet worst case scenario. And the realistic part is that many of us still have Windows XP systems in our environment, and oftentimes the Windows XP systems, in particular one that's compromised, may not be patched on a regular basis or appropriately. So I wanted to make it kind of a worst case scenario in the sense that this Windows XP is going to be very vulnerable to attacks and privilege escalation, so that the attacker essentially is going to have the full rights capable on that system to go after my credentials in any way possible. They're going to have full system level rights on the box. So I wanted a vulnerable system, but also one that we realistically could see in the wild. And so Windows XP and Service Pack 2 specifically is what I've got. Now, part of the IR mission was for me to be able to interact with that system, and there's really three things I wanted to be able to do. I want to be able to query the machine with a tool such as WMIC, which is just a fantastic tool that I use all the time. I love it. It's you can do all types of things like query running processes and logged on users. You can query services. You can even get to a registry. Basically anything that you can do with WMI, you can do with WMIC. It's the command line version of WMI. You can actually even start and run processes, which I'll show here in a moment. But I also wanted to be able to run commands, and instead of using WMIC, I wanted to test psexec because particularly in the incident response world, we see psexec used quite a bit, and it is a useful tool, but I wanted to take a really close look at this tool in particular to see how it interacted and how it may or may not expose credentials. And just to cut to the chase, and I'll try to hammer this home as we go through, there are safe ways to use psexec, and there are specifically unsafe ways to use psexec. And as I'll show you soon, the psexec, the way they use it unsafely, what can expose your credentials, is the -u option, which uses alternate credentials. This will create an interactive logon, and as we mentioned before, that's what we want to avoid. So I'll talk about it some more as we go through the presentation. The final thing is copy files to and from the machine via net use command. And so a typical scenario also for an incident responder might be that you just need to get an agent to the system to actually query it and interrogate it. So it could be something like an in-case agent or fresponse or something like that. So I wanted to be able to copy a file over, and I wanted to be able to execute it with something like psexec or WMIC. And of course, I need to be able to do all of this without giving any opportunity for the attacker to steal the domain credentials. All right, and so for effective IR, we need to have administrative rights. So this is one of the main requirements. Can't do it with a regular account, standard user account needed. Administrative rights. Now, if you happen to know the administrative account on the local machine, the local administrator account, then by all means use that. That's going to obviously prevent the domain credentials, which could be used across multiple systems in the environment, prevent those from being used. But in many cases, we don't have that ability. And for various tools out there, if we go beyond just the IR realm, for various tools that we use to maybe scan the environment for things like configuration management or patch management, vulnerability analysis, some of these service accounts that sweep our entire network, we're going to use domain accounts. So this is where it kind of bleeds over into overall domain security. We want to be able to protect these domain accounts. So as I mentioned, we've got 4 areas here that we're going to study and look through, and the first one is password hashes. So I don't want to go into great detail about the overall mechanisms for the various hashes. I just want to kind of highlight what I consider 2 types of hashes. One is what I could call the raw hashes. And these are used to authenticate this person to the local system as well as remote systems. Now, this is the landman hash and the NT hash. And you also see it called this OWF, one-way function, and specifically in Microsoft documentation. And when I say it's going to authenticate to local, this is essentially what happens when you authenticate with a local account. It's going to authenticate against a landman and or an NT hash. And also with a remote authentication, it uses the hash to answer the challenge response piece to authenticate to a remote system. So those are the raw hashes. The other hash is used for authenticating domain accounts to a local system when the domain controller is unavailable. And this is the cached credentials hash. It's a stronger hash than the others. It's essentially a hash of the NT hash, but also has the username mixed into the hashing algorithm, which is essentially used as a salt. And this helps protect against pre-computed rainbow table style attacks. So having that additional piece of information mixed in goes a long way towards protecting the cache credential. So what happens if the attacker gets the hash? Well, of course, the first thing that can happen is that the attacker could try to guess and make guesses at the hash to figure out what the password was. So these hashing algorithms are well known, and there's lots of tools out there to, first of all, brute force with just random guesses, or seed it with a dictionary attack or some hybrid thereof, and come up with a bunch of guesses to match a hash with a corresponding password. So of course, that's one method. Now, in the case of the landman hash as well as the NT hash, which are not salted, they're vulnerable to a rainbow table attack, which allows an attacker to create a massive database of pre-computed hashes, or basically password guesses to the corresponding hash. So when the attacker goes and steals a password hash, they can just go to a lookup database, a rainbow table, essentially, and look at the password hash that they stole with the corresponding password. So it turns out that the landman hash is extremely vulnerable to this for multiple reasons. And at this point, you can go online and find online rainbow tables for LN hashes and just plug in the hash and get the password spit out within seconds. So at this point, the landman hash is almost equivalent to actual passwords. This is why we've got to do everything we can to prevent the landman hash from being stored and even computed. So ideally, what you would have with a landman hash is a password greater than 14 characters. So 15 characters or higher, which completely breaks the landman hash. So now with the NT hash, they're still vulnerable to the rainbow table attack, but because there's so many more possibilities for an NT hash, they're much stronger. You don't see quite the vulnerability with them. There's online tables or rainbow tables that can be downloaded that go up to 8 characters, really even 8 to 12 characters. And there's actually something, I think it's called cloudcracker.net, a project that Moxie Marlinspike has been working on, where he's got quite a few hashes available online that you pay for a service, and you essentially can submit upload hashes and get the corresponding password back if it's in the database. But these are all ways to basically take the hash and try to get the password. So pass the hash is the other possibility here. And this is what we see attackers do so frequently, and it really just negates the whole need for trying to brute force or crack or make massive rainbow tables. And the way this works is that it turns out that when you need to authenticate to a remote system in a Windows environment, the authentication mechanism, the protocol, is actually it's a challenge response type of protocol where you're issued a challenge and you have to answer that based off of your password hash. Not off of the password, but the password hash itself. So there are many tools out there, Windows Credentials Editor, Pass the Hash Toolkit, Metasploit being a few, where if you supply the password hash, you can authenticate against remote systems as that user with just the hash. No need for the password. And this is really something that is kind of devastating to a network, a Windows environment, because it's just, once those hashes are exposed, and as long as they remain relevant, in other words, as long as the user hasn't changed the password, they're as good as the password. So we have to be very careful of this. So what has to happen to get to the hashes? Well, for a local account, the hashes are stored in the SAN database, so they're just going to be there and they're going to be available for the attacker to steal. For the domain accounts, and this is the thing that probably a lot of people haven't dug into this, don't really realize, the domain accounts are only going to be available, well, first of all, they're going to be available in domain controllers, obviously. But other than the domain controllers, the only place that they're going to be available is systems for which the user has done an interactive logon to the system. So my next slide, I'm going to talk in depth about the interactive logon. But this is a key point to help us protect against hash stealing. This interactive logon is what we really need to avoid on untrusted systems with our privileged accounts. But when we do an interactive logon, the hashes are stored in two places. First of all, they're stored as cache credentials so that we can log on to the machine in case the domain controller is not there. For example, when you log on in an airport or in the airplane or something and the domain controller is not there, the Windows host, your laptop, is using cache credentials to authenticate your domain account. So they've got to be stored on disk. Now, while the user remains logged in, those raw empty hashes, and these are the hashes that are used specifically for pass the hash, they are the ones that are going to be available while the user remains logged in memory. And they can be dumped by a number of different tools, and I'll show one here in just a moment. So the real key here is that once those interactive logons happen, we've got cache credentials on disk, and we've got, while the user's logged in, we've got the raw hashes in memory. Now the attacker has to have administrative rights to basically dump these hashes, but that's typically not a problem. Even if the victim was running as a non-privileged user, there's so many exploits out there to allow an attacker to elevate to system level rights that running as an administrator is really not much of a hurdle. Okay, so here's where we get down to interactive versus network logon. An interactive logon is the one that's going to create all these hashes. The most typical scenario is you log into your Windows desktop. Do Control-Alt-Delete, the desktop appears. This is an interactive logon. Other possibilities are when you basically get a virtual desktop. For example, Terminal Services, Remote Desktop, Citrix, VNC, Gameware, Remote Admin. All of these that present you with a virtual desktop basically an interactive logon will occur. Additionally, a run as command actually performs an interactive logon, and this is one to be careful of because say you're in a scenario where you've got a machine down the hall that you know is infected, and you might think, well, I'll just go over there, log in as a local account, and then do a run as to my privileged account to do some more investigation. Even though you're logged in, to the desktop, or that your first login, Control-Alt-Delete is with a local account or a non-privileged account, that run as actually performs a secondary interactive logon, and all those hashes and everything are going to be created on the system. There are other ways, and psexec is yet another one, which essentially allows the system to log you in to an interactive logon session, to an interactive desktop. So I've got a quote from the Windows sysinternals administrative reference here in a minute, and it'll explain that quite well. But what it boils down to is there are a few other scenarios where there could be an interactive logon, but I'm going to show you how to test for this so that you can get your tools together that you use on a regular basis and test them and see exactly what type of logon it is. Now, network logon is the other type of logon that we use on a regular basis. This is the network-based logon when you access remote file and print shares, your SMB and CIFS type connections. You're mapping a drive to a remote system. You're logging in with an MMC snap in, such as the computer management, maybe to change your local password or something. WMI, WMIC, these things are all network logons. So we'll start to do some testing here. I'm going to run through quite a few screenshots to just show you how this looks in action. Now the first thing to notice is the difference between the logon types, and luckily Windows records this in the event log as long as you have auditing turned on the system. And so again, a nice method for you to test your tools is to enable account logon audit policy, test against the system with your tools, and then check the logon types. So logon type 2 is an interactive logon. This is what we need to avoid with our privileged accounts. Logon type 3 is a network logon, and this is a safe logon. This will not create the hashes. So what I want to do is kind of run through my test scenario where I'm going to do kind of paint the picture for you. On the left, we have well, overall, we have a Windows domain environment. It's got a 2003 server. Again, we're using XP because I wanted to kind of look at the most vulnerable systems and see what was capable from the most vulnerable systems. And to be honest with you, all these things I'm looking at and talking about haven't really changed in Windows 7 and 8. So this applies from XP going forward. But on the left, I've got a compromised host. It's a user XPPC is the name of the machine. And I have two users, user 1 and user 2. User 1 is going to do a Control-Alt-Delete log onto the system. And then he's going to start up a new command window with run as user 2. So user 1 does Control-Alt-Delete, user 2 does run as. So we'll show how that looks in the event logs. Then from my responders machine on the right, I'm going to log in with a responder account with psexec, netuse, and WMIC, and show how the network logon appears in the event logs. And once this is up and running, I want to dump the hashes, both cache credentials and credentials in memory. And then we can prove, and show what the effect is of these various logons. So the first one real quick is just showing the results of the interactive logon. This is user 1, this is Control-Alt-Delete, and logs on to user XPPC. And in the bottom, you see the logon type 2. So this is an interactive logon, and this is what we would expect. Next, I have user 1 in the command shell run the run as command to start a new command window as user 2. And at the bottom, we've got user 2 as the running user for this new command window. The results are a logon for user 2. As you can see in the bottom red, we've got logon type 2, and it actually labels the logon process as secondary logon, sec logon, but an interactive logon nonetheless. Again, a logon type 2 interactive logon. Okay, so I'm going to use the little pointing tool here. I'm going to hope this works. So it's a busy screen, but what I want to point out is that at the top, so this is basically my responder account mounting the commands against the remote system to do triage essentially. So this is going to be the netuse, the WMIC, and the psexec against the compromised host. So what I'm showing at the top is essentially responder 1 logging in, or is actually logged in, and the second command shows that it's on the IR system. Now the next step is going to be to do the net use against the user's machine and to map a drive to the C admin share. I'm showing the times here, which is not that important. Next, I'm going to do the WMIC. Now, typically, what I would do with WMIC is just do a query, such as find out the logged on user, or maybe find out the operating system level, or something to that effect. But I wanted to do something that was more persistent than that. So in this case, what I actually did was I ran WMIC against the remote host, user XPPC, and I started up a new process, and that process is ping minus T, which is a continuous ping, against the local host. So this ping is just going to keep running in the background until I eventually kill it through my task manager. But I wanted to keep this process running that I created as my privileged account on the compromised host. So something else to point out is that this is process ID 1996, and we'll see that here in just a few minutes as we look at some logs. And then finally, I did a psexec against the remote system and launched cmd.exe. And this essentially gives me a command shell on the remote system, and it's very much like a telnet or an SSH type of connection where I have interactive capability to run commands and get the output back. Now, one thing I want to note is I did not use the -u here. I just used the built-in credentials of the logged on user, which is my responder account, but I did not specify an alternate user with the -u option. So at the bottom, I'm just showing primarily that now that I've run psexec and a command shell against a remote system, I can run commands on that remote system. So I say host name, and the result is user XP. So I'm actually running commands on the remote system. So we'll take a quick look at the logs. This is the event log from the event logs for the netuse command. It's at the right there in the middle is the logon type 3. This is a network logon, which we would expect, and which is the safer method. This is the events that happen from the WMIC. We actually have a logon type 3 here, which is what we want to see. And within the same second, we actually see the WMI provider service launching ping.exe as responder 1. So this is me running responder 1. And also the process ID is 1996, like I mentioned before. So we're going to see that this 1996 just continues to run. This process continues to run for me. Now this is what happens with psexec. It's kind of a wild setup in the sense that it does a lot of things. Basically what happens when you launch psexec against remote systems is it's going to copy over its executable. It's going to install itself as a service, and so the first, in this little waterfall of events, the first thing you see is the service manager kicking off, and the second thing you see is the psexec service being run. And then at the bottom we actually see psexec service running and launching cmd.exe as my responder1 account. So these are all the things that we would expect with a psexec connection, but again, this is not a psexec -u, this is a standard psexec without the alternate credentials. All right, so again, another busy slide, but let me just walk you through it, and we'll see the results of dumping hashes at this point. So the first two commands, essentially the net sessions, I want to show that my responder1 account is still logged in with the net use command, and I wanted to query the process for ping.exe to see if it was still running, and sure enough, my ping.exe is still running as process ID 1996. So my user account that we saw the logs in earlier, my responder account, has initiated this process and it's still running as I dump password hashes. So I'm going to use two tools to dump password hashes. The first is Windows Credentials Editor, and it's aimed at dumping those raw hashes, the NT and the LM hash, straight out of memory. As you can see here, it's able to get user 1 and user 2. Those are our two users that were logged in. And I must have had the local administrator account logged in at that point too, probably with another command window. And it also dumped the hashes of the actual PC. But what you do not see is the responders hashes in this list. It was not able to find my responder account's hashes despite me logging in with psexec, WMIC, and netuse because they were all network logons. And with cache dump, it's going to dump its cache credentials. And the cache credentials are the ones stored on disk. It finds them for user 1 and user 2, and also for user 4, which I must have logged in with sometime prior to this testing. But it does not find them for my responders account. So this is really, really good. It basically enforces the things that that I found. And I should mention also that this basically requirement for an interactive logon to load hashes and everything, it is documented by Microsoft. It takes quite a bit of digging to kind of come across it and maybe to interpret it, but it is documented that this is how Microsoft works as far as loading up hashes and the credentials with an interactive logon. So at the bottom, I'm simply just showing that my net use is still logged on as responder1, and my process of ping.exe is still running. And psexec was running as well. I just couldn't fit it all into one screenshot. So what are the takeaways from this? Essentially, with an interactive logon, those hashes are available, and that's a bad thing. So we need to avoid interactive logons. When a network logon is done, the hashes are unavailable, and this is exactly the way we need to approach with our privileged accounts against untrusted machines. We have to rely on network logons to get us the things that we need. So as I mentioned, I did WMIC, netuse, and psexec. I also have done things with MMC and regedit remotely and other tools as well. But feel free. I mean, what you want to do to get good feeling about the tools that you're using is test this out. Turn on event auditing on a test machine, run your tools against it, and query and really look closely at those event logs. So just another point though before we move on about psexec. Again, psexec -u does create an interactive logon, and this is what we have to avoid. And I'm just going to read straight from Windows sysinternals administrative reference. He says specifically, when explicit credentials are supplied, and this is the -u option, they are used to authenticate to the remote system. So the first, there's actually a network logon. So they authenticate the remote system with a network logon, and then to create a new logon session that can run on a particular interactive desktop. And this is the interactive logon. It also mentions, which is important too, is that the username and password used to create the new logon session are transmitted to the remote system in the clear. That is unencrypted. So, the takeaway here is do not use psexec -u. That's the whole key. And it may bring up one more point, is that you probably need to look very closely at these logs, because actually, if you had done a psexec -u as your test and just looked for the very first logon, you would have actually seen a network logon, but it turns out there was a secondary logon later. and that's the interactive logon. So you know, take care and be meticulous about looking through your logs when you're testing your own tools. I can think of another tool which I've done a little testing with is xcmd.exe, which is kind of an open source version of psexec, and so far I have not found a way to do an interactive logon with it, but I haven't looked at it in depth. Of course, there's other tools out there that probably can do some similar things, so take care to look closely at those logs before you deem it absolutely just a network logon. Okay, so let's move on to encrypted passwords. Now this is really a new finding. Just last year, a researcher in France named Benjamin Delpini discovered that Microsoft stored the user passwords in memory. And as far as I can tell, no one realized this, you know, for years, and this has been around since at least XP. It stores it in for various, well, in what's called security service providers, and the whole idea is for single sign-on to various services that don't support the native Microsoft authentication packages. Now the password is stored encrypted in memory while an interactive logon is in session. But although it's encrypted with a standard Win32 API function, and there's a standard Win32 API function to unencrypt it. So it turns out that Benjamin wrote a tool, WEBCAST, that is able to dump those clear text passwords straight out of memory and present them to the, you know, to the person running the tool, and it's essentially just a dump of your clear text password. So this is a screenshot of Windows 7 showing 3 of these security service providers that store the password in memory. Kerberos does, just notice I misspelled Kerberos, but Kerberos does, WDigest, TS Package are 3 that store the password in memory for single sign-on purposes, presumably. I'm honestly not sure about Kerberos. I don't understand why it's there. We can dig into some more. Maybe someone out there can enlighten me. The reasons for WDigest is an add-on essentially that allows you to authenticate to web services that don't support the native NTLM or Kerberos. So that's the reason for having that as a single sign-on functionality. TS Package is the internal service package, you know, security package that's also there for single sign-on to various pre-configured remote desktop sessions. So you also notice, and this is Windows 7, and of course it's going to be in Windows 8 as well, a built-in one for Live SSP, which is the Microsoft Live.com services, which with Windows 8 you can actually log into your desktop with this account. And of course Microsoft is going to handily keep us our password cached in memory through this security service provider. Now well, actually, back up. Let me just go ahead and show you what we've got here as far as how the tool works and the output that it gives you. What I did was I set up a test system. This is Windows 7 64-bit. And I logged in with 2 accounts. I logged in with my Responder 2 with the Control-Alt-Delete, and I logged in with Responder 1 with my Run As command. And as you just scan down, you can actually see the passwords that were dumped out of those 3 vulnerable security packages, Kerberos, WDigest, and TS Package. Now on the top right, I actually have my password set to, you know, this long string of characters, 21 characters long, which as you'll notice actually caused the LM hash to be zeroed out because it's more than 15 characters. So it's actually a pretty strong password. It's not all that random, so it's not the best, but it's a strong password, breaks LM hashes. However, because of this storing of the passwords in memory, we can just dump the actual password out with Mimikatz. And then below is Responder 2's password is just Responder1-PW1. So it's just as simple as running a quick command and dumps those hashes right out for you. Or sorry, I said hashes, dumps those passwords right out for you. Now, Benjamin, in one of his blogs, kind of proposed the idea of, well, what if we just remove these security providers since we don't need them? Now, he did this, the first 2 that he discovered were WDigest and the TS Package. This is before discovering that Kerberos was vulnerable as well. So the idea was, well, do we really need this, particularly on, say, trusted machines that are specifically used for things like IR, or you know it's a specific machine that's used to scan your environment. You probably don't need a lot of single sign-on functionality. So the idea was just remove the packages. So actually that works quite well. And in this test, I just basically removed those packages, rebooted my box, and then ran the tool. And at the bottom, you can see those are my responder 1 and responder 2. It did dump the hashes, but it could not find the passwords. So in theory, it would be nice. However, because Kerberos is one of the vulnerable protocols or security packages, we can't really function without Kerberos, and we wouldn't want to. So at this point, really the best defense for this particular attack is as simple as avoiding interactive logons. So yet another reason to make sure that with your privileged accounts you're doing network logons and not interactive logons. Okay, so the next area is access tokens. And access tokens are one that I wasn't really familiar with and have been digging into, and finally have a pretty solid understanding of what's going on here, but it is a little confusing. So hopefully I can do a decent job of explaining this. The tokens are a little bit like a web cookie or session cookie is the way I think of them. They actually hold some identity information about a user, including security permissions, and they are applied to processes to give security constraints to that process. So every token has to have a primary process, every process has to have a primary token. And that's what basically puts some parameters around the security capabilities of that process, what it can do, what it can get to, and things of that nature. Now there's also an impersonation token, and this is the one we need to focus in on. And the impersonation token is used primarily for client-server scenarios where, for example, when logging into a remote system, the process, let's say we're going to log into, for example, an FTP server, say a Microsoft FTP server. When we log into that FTP server, the process that runs the server is going to have the user's security constraints in mind when it starts to run threads and to do work for that user. In other words, it needs to know inherently what files and folders that the user has access to. And the way it does this is by impersonating the connecting client for a brief period of time so that, again, it inherently understands and knows what it can access and what it can't. So this is why a process would impersonate a user for a short period of time. So there are really two levels of impersonation that we need to be concerned of. Actually, I'll go back one. I forgot to mention that. There are 4 here at the bottom. The first 2 aren't used so much. The second 2 are the ones that we want to look at, and I'm going to just do a deep dive on this slide. The delegate-level token is the one that we have to be very, very cognizant of and aware of. It essentially allows what's called the double hop. It allows a user to connect to a remote system, and then through delegation, that system can connect as that user to a third system. This is a big security concern, so we have to take a lot of care of our delegate-level token. Now, the impersonate-level token is more for a standard connection to, say, an SMB server, where I need to connect to the remote system, and that remote system needs to impersonate me for a short period of time so that it knows what I can get access to, but there's no need for it to then authenticate to another remote system. So impersonate level is only going to allow the process to do work for the user on that local system. Now, I should note that there is the possibility of a local privilege escalation attack by stealing the impersonate level token. So, for instance, if an attacker had a lower level right but had the ability to basically latch on to a local impersonate level token, they could escalate privileges. But in my scenario, this is not really a concern, because what I'm really focused on is that we understand, well, first of all, we think that the attacker already has full system level access to the box. Now, if they don't, and if you're super concerned about that, you may want to look at doing an offline analysis instead. But the other part of it is we've already established that we need to do we need administrative rights on that box to fully query it and to triage and understand, what's going on the system. And it turns out that whether I was using a privileged domain account with administrative rights on that system or a local account with administrative rights on that system, it really doesn't matter. There's no additional exposure by using a privileged domain account. The attacker could elevate and escalate privileges with that token of the privileged domain account, but it can't do anything off the box as the domain account. So that's the key. But again, if you're in a scenario where you think, well, maybe the attacker doesn't have the ability to escalate to, admin or system level access on that particular system, and it's a very sensitive system, then you may want to look at doing an offline analysis rather than connecting to it and exposing the impersonate-level token. Okay, so when did these show up? The impersonate-level token, again, is the typical scenarios logging into a remote system for something like SMB or FTP, in the case of Microsoft FTP or HTTP. What happened is that the local system can impersonate that user only on the local system. And we'll see these impersonate-level tokens show up through this type of network logon, the remote system. The delegate-level token is going to be available with an interactive logon, but we've already seen there's so many vulnerabilities we need to avoid interactive logon anyway. But it's also available with some non-interactive logons for certain services. So encrypting file system is one example where the file server is actually going to encrypt files on behalf of the user using their delegate-level token. So if you are doing, say, instant response on an EFS server, be aware that this could certainly grab your delegate-level token and cache it there and have it available. Another solution, which is probably even more likely, is multi-tier solutions such as SharePoint. And in this scenario, a typical SharePoint installation is going to involve kind of a front-end web server and a back-end SQL server. And this really kind of demonstrates the need and the usefulness of this double hop capability with the delegate-level token. So that when I log into the front-end web server of SharePoint and I start browsing through the files and folders and stuff, and then I click on a file that I need to access, the front-end web server is going to use my credentials to log into the remote system, to the back-end SQL server system to gather that data and gather those files for me. And it needs to authenticate to the back-end SQL server so that it knows what files I have access to and which ones I don't. So there are some very good uses for this delegation, and SharePoint is just one of those examples. So when does delegation come into play and how can it be used? It essentially requires one of two things. It requires either the computer itself or a service account, essentially a domain account that's created to run just that service, to be trusted for delegation. Now, probably the more secure setting for this would be to specify just a particular domain account that you might label as a service account that might run the IIS services for SharePoint, for example. That account would be trusted for delegation, and that account would only be used to run that particular IIS service on the front-end SharePoint server. Now, when it is trusted for delegation, then when we connect to the remote system, if we are allowed to produce our delegate-level token, then it will be cached. Now, I'm going to show you a way here in just a second how we can prevent that delegate-level token from being created, whether or not the computer or account is trusted for delegation. But this is the requirement to allow delegation to occur. Okay, so let's just walk through a quick scenario. Now, I've tested WMIC, net use, and psexec again. And psexec actually, even without the -u, will create a delegate-level token on a system that is trusted for delegation. So I set up a trusted system for delegation, and I use psexec against it. Now, this is again my IR account. I'm logged in with my IR account, and I am using psexec against remote system, again without the -u, but launching cmd.exe. And so now I am on the remote system user XPPC, and I am responder 1 on the remote system. Now, the tool that's used for stealing tokens is called Incognito. It's written by a guy named Luke Jennings, and he's written an excellent paper to go along with it. So I have a link to that at the end of this presentation, and I recommend reading through it. It's very, very good. He has a standalone tool, but he also has built a interpreter module for it. And I found the interpreter module to be a little bit more robust and stable in my testing. So I'm using the interpreter module. And what I've got showing here is a interpreter session on the compromised host, the one that I just logged into with my privileged account. Now, essentially what happens is, I'm just going to kind of walk through these steps. I had to elevate the system, so I used built-in vulnerabilities or built-in exploits within the interpreter to get system-level access to this box. So then I said I want to use the Incognito module, and it downloads the Incognito module into the interpreter on the compromised host. I list out my tokens in this fourth step here, or fourth command, and sure enough, my responder 1 is a delegate-level token that's available. So since it's available, I'm going to then impersonate the token as MSAD responder 1, and it's successful. And at this point, I can use the shell command within my interpreter to actually launch a Windows CMD shell and run standard Windows commands like hostname, and showing yes, I am connected to user XPPC, and yes, I am MSAD responder 1 at the bottom. So continuing on, I want to just kind of show what's possible now that I am responder 1 and I've got the delegate level token, which allows me to authenticate to remote system. So again, who am I? I'm responder 1 on the user XPPC. And I'm going to use net use here to map a drive to the domain controller. The domain controller here, MSAD DC 2K3, and the C dollar share, the C admin share. I want to map a drive, and I'm able to map a drive because my responder account is a domain admin, and he has just made it easy and given full privileges throughout the domain for this account. The map drive was successful, and now I can do a DIR against the entire O drive, which turns out to be the domain controller C drive, and look for backup files. I found a backup file, and I used copy to just copy over that backup file to my compromised host. So I copied over the domain controller's backup file, which includes the Active Directory store, including credentials and hashes, copied it back to my system, and my compromised system, and then from the compromised system, the attacker can easily get it back to their own system. So this is all the type of lateral movement that's capable out of a delegate level token, and this is why we have to take care of protecting these delegate level tokens. Now the great news here is that Microsoft provides us a way to do this. They've got a setting within any accounts, user accounts profile to say account is sensitive and cannot be delegated. And that's the check mark I have here. When you set, and I should mention that Microsoft, there's a few places where they definitely recommend doing this for your sensitive accounts. And I've done this for multiple accounts. I haven't seen any, both my work and in testing, and I have not seen any ill effects from it. And if you think about it, it makes sense because most of our privileged accounts, they don't need this double hop capability. Now, if you were to do this to your standard accounts, you probably would run into issues, particularly if you're in a SharePoint type environment or you have this kind of multi-tier solution. You may very well run into problems. And nevertheless, whether it's the privileged account or not, you should obviously test this out. But in my testing, I haven't seen any problems. Microsoft recommends it, and it prevents that delegate level token from being created on a system that's trusted for delegation. Oh, how in the world did that happen? Let me see if I can, sorry about that, hit the wrong button. If I can flip through. Okay, sorry about that. So now we've got the new settings applied, and I rebooted machines. I logged back in, did all the same steps as previous, tried to do the net use with my responder accounts, actually showing me responder 1. I was able to basically impersonate the token, but then when I try to do the access to the remote system, I get an error occurred. And here we have the actual event logs. It's a little small, hopefully you can see it. But basically what happened is although I was logged in, quasi-logged in to the compromised host as my responder account, when I tried to authenticate to the remote system, it was a login as anonymous. And so the anonymous logon is going to fail, of course, to the $C share of the domain controller. So the good news is it worked as expected, and again, Microsoft recommends this. Now for WMIC and net use in my particular testing, it didn't matter. It did not create a delegate level token, but psexec, even without -u, did create a delegate level token. However, the easy fix here, and what I would recommend for IR accounts and for many of your service accounts that are sweeping the network that probably have no need to do this double hop, is set that account as sensitive and cannot be delegated. That way that delegate level token is never created and never exposed for an attacker to steal. Okay, so the last leg here, we're on to network authentication. And it boils down to, there's a number of different protocols here that are available, some kind of iterations of LAN-man challenge response and NT LAN-man challenge response, and then Kerberos. All of these are designed to take those hashes that we talked about and use them in a cryptographic way to answer challenges to allow you to authenticate to a remote system. And the remote system, if you get the answer right, it knows that, yeah, you can log on to that system. So it's a way of authenticating remotely. Now, all of these, from LAN-man challenge response to NT LAN-man challenge response and the version 2 and Kerberos, they're all still available even in Windows 8. I'm going to run through a couple of problems, and then what I consider the main solution is Kerberos, but then we've got a caveat with Kerberos too, so we'll have to work through that. But the first problem with the version 1 of the LAN-man challenge response and NT LAN-man challenge response, and the reason why you need to move on to version 2 is essentially boils down to the fact that the first version did not provide mutual authentication. It only authenticated the local user, it only authenticated the client, not the server. So you can see kind of the process here. We've got a request for logon, and we've got on step 2, the server issues the challenge, and then in step 3, the client uses those hashes to answer the challenge. Now the problem here is because the server is never authenticated in any way, the server can issue any challenge at once and get sensitive information back. It can get an answer. And so a typical attack for this would be issuing a static challenge for which the attacker already has a huge rainbow table computed for lots of answers for this particular challenge. So this is what can enable, and Metasploit has a capability to do this, and a number of other tools. They'll use actually a static challenge that they'll show here, double 1, double 2, double 3, and so on. And so actually this makes for a nice little IDS signature if you're so inclined. But basically the whole problem here is that we're essentially divulging sensitive information right off the bat, and we expose ourselves to kind of a pre-computed attack by allowing the server to just give us a challenge, a static challenge, and if so desired, and it will answer that challenge with our sensitive credentials. So the fix to this is version 2, which adds mutual authentication. The way it does it is essentially allows the client to include its own challenge in the answer. So step 1 and step 2 is the same. The server is still going to issue a challenge to the client. But when the client answers it, it's going to be based off of the server's challenge, but also its own challenge that it can generate randomly. Now the server is still going to see the answer, and of course the protocol is well known, so the server, if it's a rogue server, certainly has the ability to take that answer and the challenges and try to do a brute force attack and determine the password or the original hash that created that answer. But it's going to be much more difficult, and there's no pre-computed rainbow table attacks available for it. So we want this mutual authentication that's given to us by version 2 of the protocol. Now, here's another problem that turns out to be more difficult to tackle, and the first version of the problem is what's called a reflective attack. Now, this was fixed in 2008 with this patch MS08-068. And essentially what it allows to do is allows the attacker to turn the tables back on the client. And while the client's able to log into the server logs right back into the client using the same challenge and answer provided by the client. The patch actually fixes this specific problem, and what it does is it allows the client's SMB server to watch, or actually, I'm sorry, it allows the client's SMB client from answering challenges that its own server has recently issued. So this is something that we want to include. I'm sure most of you have this. But the bigger problem, which is much more difficult to fix, is related, and it's the relay attack to a third machine. So I'll just talk through this one real quick. In step 1, we have the client connecting to the rogue server. And in step 2, the rogue server forwards a logon request to a victim machine that it wants to log into. In step 3, the victim machine issues a challenge back to that rogue server, and the rogue server issues that exact same challenge back to the connecting client. The client answers it to log into the rogue machine. The rogue machine uses the exact same answer to send on to the victim machine on the right, and is able to log into our victim. So this is a very difficult problem to solve, at least in the sense it can't be patched like 08 was. It's not feasible for everybody's client to be listening to everyone else's server and not answer the same challenges. And in a big environment, there'd be probably natural collisions anyway. So that's not an answer. Now the tools that are out there to do this are SMB Relay 3, Metasploit, there's probably some others. Currently, to my knowledge, NTLM version 1 is only supported, but version 2 is possible. If you kind of do the arrow math, you'll see that it would work out, and it can work out, and it may very well have worked out already with some tools out there to allow the same type of relay to happen with version 2 of the protocol. So we talked about the fix for reflective attack as adding this patch MS08 068 should be no problem. For the relay attack, it's a little more difficult, and you'll see out there some documentation that says that SMB signing is maybe the best approach to fix this problem. I kind of disagree with that, and primarily because, if for no other reason, SMB is not the only service that uses NTLM. So while it's possible, although I don't think it is true, but even if it's possible for SMB to fix this problem with SMB service, what about the other services? So the best fix out there is a feature that Microsoft enabled or created for us a couple of years ago called Extend Protection for Authentication. And what this does is essentially it creates a service principal name in the request, and it signs it with the account's credentials. The service principal name is a unique combination of the remote system's host name and the service that the client wants to connect to. So what this does, and by signing it with the account's credentials, what this does is that if it gets to the rogue server can't take that request and forward it onto a third server because it was created with the service principal name of the rogue server, not the third server. The third server would see it and say, oh, I got to drop this, it's not for me. Also, the attacker cannot, the rogue server and the attacker on the machine can't create their own request to the third system with the third system service principal name because they don't have the credentials to sign the request. So this is a very useful and effective fix. The only problem with it is basically it boils down to do it effectively, you really need to turn it on throughout your environment. Now, it could be that you have one particular server or set of servers that are very sensitive, where the secret sauce is stored, and you might want to say, okay, only these systems are going to have and enforce extended protection for authentication. That could be a relevant scenario. But overall, you'd like to have it throughout your environment to prevent lateral movement to other hosts and clients out there that could be vulnerable and not enforcing it. Because if it's not enforced if it's not enforced by the client or by the server, then the client can just say, oh, I don't support that, so I'm going to downgrade to not supporting extended protection for authentication and not have this feature built in. So ideally, you would deploy it everywhere. But there could be certainly some benefit to even applying it to your most sensitive servers out there. So the big problem really with NTLM and Landman Child Response, both versions, is an overall weakness in the design. And what I'm showing in the screenshots previously was really what happens when a client logs into a server using local accounts. I didn't really show the next step being a domain authentication. So this screenshot shows what happens when a user connects to a server in a domain environment with domain credentials. So really the first couple of steps there, 1, 2, and 3, are the same as what we saw before. We've got a request logon to the server sends a challenge, the client answers the challenge. In step 4, the server takes the challenges and the answer and sends them over to the domain controller to authenticate them, because the domain controller has the hashes and can do the computation to figure out if the client answered it correctly. So the domain controller does this, sends it back to the server, and the server, is given a heads up, yes or no, the authentication was successful or not. But the problem here is that the server is always man in the middle to this entire exchange, and that's just an overall design flaw. So the big fix here is Kerberos, which takes out that man in the middle piece. And now what we have is the client connecting directly to the domain controller for all of the authentication pieces and getting a ticket that allows the client to access and authenticate essentially to the remote system without the remote system being man in the middle. So the first 4 steps here are all about negotiating, getting authentication for your ticket, and then you send the ticket to the connecting or to the remote system, which grants you access. And there's that service ticket that sends the remote system has the same type of technology as far as the embedded service principal name that's going to make it unique to just that server too. So that's also another feature that helps prevent this kind of forwarding of credentials. The downside of Kerberos is that we can't use it in all cases. You still just cannot get rid of NTLM in all cases. And I'll just focus on really this first bullet, basically, is where it boils down to, the first blue bullet. The client is authenticating to a server using an IP address. This is when NTLM still must be used. And one of the main reasons for this is because Microsoft, by default, does not create a reverse lookup zone in its DNS server settings, which means that Microsoft doesn't have a way of specifically identifying our remote system's name with the IP address, based on the IP address. And Kerberos wants to embed that service principal name in the request, but it can't rely on the host name when you give it an IP address. And this is basically what it boils down to on why Microsoft will want to fall back to NTLM when you specify an IP address. And this is a problem for us because there are a number of services out there where you're going to want to use IP addresses. I mean, I can think of a number of our service accounts that are used to essentially sweep networks, and they're probably not going to sweep. I mean, some may sweep by host name, but others are going to you're going to feed it an IP address range, a network, and it's just going to go and connect to everything out there that's available. And there are other scenarios like in the IR world where I run into a lot is with, say, a VPN client that's just connected and hasn't yet updated DNS, so we don't know the host, we may know the IP address of it, but when I do resolution, it resolves to either nothing or to an old host name. So this becomes a problem. But of course, Kerberos does work a lot of the time, and when it does work, we need to, and when it's available, we need to use it. So the nice thing about Windows 7 in 2008 is that we have the ability to enforce the use of Kerberos, i.e., in this case, actually restrict the use of NTLM. And this is available to us in the local security policy. So in my screenshot here, I have, towards the bottom, I've said I want to restrict NTLM to remote servers. I want to deny all to remote servers. Now the other thing is we actually have the ability to put in an exception list. In this case, I configure an exception list of 192.168.6.12. So this comes in handy if you know, for example, you've got a proxy server that uses NTLM and you want to just go ahead and hard code in. And this works for host names as well, but if you want to just say for sure, this IP address or this host name is safe for NTLM, we'll put it in the exception list. So let me just show you a quick example of how this works, and I'm going to specifically show you for this exception of 6.12. What I want to do is force the use of NTLM against that 6.12 to make sure it works. So I do an NS lookup very quickly here to show IRXPPC does correspond to 6.12, and then I use netuse to connect to that IP address. Because I'm using the IP address, it's going to force the use of NTLM, and it works. The command completed successfully. The next step is I want to try a different system that's not in my exceptions list. So I do a NS lookup for user XPPC. This resolves to 6.11. When I try to connect to 6.11, I get an error. It does not connect. It's not successful, and that's because it used NTLM, but this IP address was not in my exceptions list. Finally, when I do the exact same command but use the host name instead of the IP address, it completes successfully. So it worked with Kerberos. It failed with NTLM for that .11 IP address. And here's what it looks like actually in the event logs. Windows does track this in the event logs for us, and you can see that it reported that it blocks the connection, the NTLM connection to 6.11. Now, in my testing of WMIC, netuse, and psexec and netuse work great with Kerberos, no problem. For whatever reason, WMIC by default wants to use NTLM. Luckily, there's a switch to make this work. It's a very painful switch, but you can type it out. And actually, in an upcoming blog, I do have one more blog well, at least one more, but coming up very soon on specifically this area of network authentication. And I've got just a short little batch file that you might want to use instead of typing all this out. But there is a switch that you can use to enforce Kerberos authentication against the remote machine. And what you can see here is when I still had my restriction in so that I couldn't use NTLM against this IP address or this system, and it failed when I tried to do WMIC against it. But once I used the forcing of Kerberos, it actually worked. So NTLM would fail, but Kerberos, once I forced WMIC to use Kerberos, it worked without a problem. So to sum up, basically how to use our stronger authentication types. We want to use Kerberos whenever possible. Now, there are times when you can't do it, and one of those tricky ones is with the IP address. There is one little trick, though, and one of the scenarios I gave was if you know, for example, maybe you've done an NVT stat minus A against a remote IP address, and you know for sure what that host name is, and that's what you want to connect to, but it's not resolving in DNS. You can actually add it to your local host file on your system temporarily so that your local system can resolve it correctly, and that will allow Kerberos to work. So there's a little fix, a little workaround for you. But go ahead and, when possible, enforce the use of Kerberos by restricting NTLM, by blocking NTLM. Now, when you must use NTLM, you want to make sure that you're using the version 2 of NTLM and not the older version 1, so you want that mutual authentication. And you also want to force NTLM versus landman challenge response. You don't want that landman hash created for various reasons. So make sure to use the long password greater than 14 characters. And finally, at the bottom there, if you're still having problems authenticating to a remote machine with these settings, you need to be very suspicious of it. Very, very suspicious. So you may still decide you want to do a remote access to it and maybe lower your settings, but I'd probably change my password very quickly, or consider doing some type of offline analysis. Oh, wrong way. All right, and then this just kind of wraps up all the findings. Again, kind of in bold, the top 3 in bold are just really essentially the 3 things that I found that you can do to lock down and protect and defend those sensitive accounts. Avoid those interactive logons. That is critical. That's really critical. Set the account as sensitive and cannot be delegated on your sensitive accounts. This is an easy win, and again, in most scenarios for a kind of a purpose-built privileged domain account, you shouldn't need this ability to do the double hop anyway. So go ahead and set account as sensitive and cannot be delegated. And then, of course, force the use of Kerberos wherever possible, and use a long passphrase greater than 14 characters to break the landman hash and force a stronger, more difficult passphrase to brute force if they get to that capability. And the last slide here is really just about a couple of other ideas for detection. For example, we've got, log management is going to be your best friend here. Look for unusual logons for unusual times, unusual places for your privileged accounts to try to detect, the possibility of stolen credentials. And additional protections, one idea is essentially kind of segment off these privileged accounts as much as possible. I know that gets hard, particularly for some of the service accounts you use to just, ideally sweep across the entire environment. But maybe even just for your IR team, give them a set of accounts that just are by region or by system type, so that if one of them's compromised, it's, you don't lose the keys to the kingdom. And then another idea is kind of a solution that I think is very useful is privileged account management solutions like those from Lieberman and CyberArk and Quest, where one of the possibilities and scenarios is that essentially they manage your account, and so that someone who needs access to a privileged account can go and check out the account and use it for a certain time period, say 4 hours or something. And when they're done, or when the time is expired, they check in, the account's checked in, and that account's password is reset with a long, strong, random password. So it really minimizes the exposure to a possibly compromised account, so that at least, for a short period of time there may be some exposure, but at least it's going to be, those credentials are going to be null and void once that time period expires. So that's everything. I've got a couple of references listed here. I really recommend, taking a look at the SANS for these blogs that I've done. At this point, I've covered password hashes, the encrypted passwords in memory, and access tokens. And I have the one for network authentication written up, ready to go. I just need to review it a couple more times, and I truly expect that to be out on the SANS Forensics blog next week. So I think we're going to open up to some questions, and also you can email me questions or find me on Twitter. And another possibility is if you have a specific question, go to the comment section of the particular blog and maybe add it there so that a lot of people can see the questions and answers. But that finishes up my presentation.
Alrighty, we do have some questions for you, Mike. 1 second, let me pull these up. Could you please elaborate on interactive login?
Elaborate on interactive login. So the key to interactive login is essentially when you're presented with a desktop. So again, like you're sitting in front of the system, Control-Alt-Delete, and you're presented with a desktop. Another one is virtually using like remote desktop or Citrix or VNC. All of those are going to provide an interactive logon to the system. And the best way to really feel it and understand it and know it is to actually do some testing and to make sure your event logs and audit settings are there to capture logon events. And do some various logons to the system and look for your logins in the event logs and see which type it is. So type 2 being an interactive logon and type 3 being a network logon.
Alrighty. Does the act of connecting to VNC when using VNC Enterprise cache credentials, or is the subsequent Windows login required when the remote desktop is shown in VNC? It's kind of a longer one.
Yeah, I'm not sure, to be quite honest with you. I've played with VNC here and there, so I'm not sure about that particular feature, to be honest with you. My feeling is that if you're logging on to the desktop itself with VNC, then you are creating cache credentials. Now, I know it could be possible for an account to already be logged into the system, and then you connect to VNC with a separate account that's just associated with VNC, and that may be a whole different thing. But if you're logging in, if you're getting a desktop presented to you and you are the person logging in to that desktop, then that is an interactive logon. And again, doing a little bit of testing with the event logs is a great way to find out for sure.
We have some that just came in. Have you studied Xcopy over net use in moving files from to remote computers? Are these interactive or network type logons?
They should be network type logons. I mean, Xcopy I do use on a regular basis. In fact, that's what I use to copy over agents and configuration files, and it's essentially a network logon. It's a little different than what I did with NetUse, where I actually mapped the drive, but it's the same idea. As essentially, it's instead of mapping the drive, you're copying it over to a UNC share or UNC path, and there's a network logon to that remote system. So that's a safe practice to use the Xcopy to copy files back and forth.
Right. Up to how many cached hashes there will be?
That's a great question.
Will there be?
By the cached credentials, I should have mentioned this earlier, by default there are 10 on a system, on a workstation, I think servers too, but that's configurable and it can be set to 0. Now on a laptop, particularly a laptop, you probably won't want to do that, but you could probably set it, to a smaller number on a laptop, and then for servers, it's very likely that you don't need to set it at all. I mean, in other words, you could set that number to 0, and you could basically just enforce the use of the domain controller being there and not have those cache credentials sitting around.
Okay. Stored in memory while the user remains logged on. Is the memory explicitly cleared, or can the hash be recovered after the fact? Is the behavior the same across Windows versions, even if it's done on XP Service Pack 2?
Yes, the behavior is the same. It hasn't changed, and the hashes will be flushed from memory when the user logs off. So, there are times when you need to do an interactive logon with a privileged account. And in those cases, just make sure you log on and log off fairly quickly. Don't stay on too long. But yes, they are flushed once the user logs off.
Gotcha. Just got one more for you. Would run as include UAC prompts?
Not that I have seen. So I'm trying to think real quick if I've seen that. I use run as pretty regularly. And typically what I'll do is I will log in with my standard user account, and when I need to interact with the remote system, I will generate a command shell, do run as command shell as my privileged domain account. And then within that command shell is when I start doing things like WMIC or even psexec, just like I showed it in that in the screenshot. And that way, my session is logged on to the local system only, my trusted workstation, and I don't have to use alternate credentials. But using the run as command in that way is actually very helpful and allows you to use your privileged account on a local trusted system without exposing it on the remote system.
Alrighty, I think that's all we're going to have for today. Thanks so much, Mike Pilkington, for your great presentation, and special thanks for bringing this to the SANS community. To our audience, we really appreciate you listening in. For a schedule of all the upcoming and archived SANS webcasts, please visit sans.org/webcasts. Until next time, take care, and we hope that you are able to come back to the next webcast.
All right, thank you.